All right, today we are solving systems of equations by using elimination, not substitution anymore. We're using elimination now. So for elimination, exactly what you think when you hear the word eliminate, something's going to cancel. Something's going to go away. Something is going to eliminate. So if you treat these two equations like they were like they're old school math problems, how your elementary school teachers used to put 2 plus 2, stack them on top of each other, and you put a 4 at the bottom. It's almost the same thing here. Okay, we want to align our like terms. So we have our x's on top of each other, we have our y's on top of each other, and on the right hand side of the equal sign we have our constants on top of each other. So all we are going to do here is combine our like terms. So when I combine these x's, negative x plus x, negative 1 plus 1, those x's cancel or they eliminate. When we combine our y's, positive 3y's plus 2 more y's, that gives me 5y's. And then on the right hand side, when we combine these like terms, negative 7 plus 2 gives me negative 5. So since my x is eliminated, then the only thing I have left to solve for is y. So since my 5 is attached to my y, I will divide by 5 on both sides, and I get y equals negative 1. So again, when we write our solution, we want to write it as an xy coordinate. The x always comes first, the y value always comes second. So my y value here is negative 1. Now, I'll take that negative 1, and I need to plug it back into one of my original equations so I can actually solve for x now. You can choose either equation you want. It does not matter. All right. In this case, I will just take the bottom one since x is already positive. So the bottom equation, it says x plus, well, it's not going to be 2 times y anymore. It's going to be 2 times negative 1. And anytime we plug a number in for a variable, and anytime I'm plugging a negative 1 into the y, I use parentheses with it. And that equals positive 2 to finish that equation. All right, so now we just solve for x. We've got our x here. Positive 2 times negative 1 turns into a negative 2. And solving for x, we will add, not 4, we will add 2 to both sides, and we get x equals 4. So since x is 4, we will put that in the solution. So our solution is 4, negative 1. The x value is 4, the y value there is negative 1. All right, so that last problem, it was nice because it was already set up to eliminate for us. Here, if I combine these x's, those don't eliminate. If I combine these y's, those don't eliminate. So, since nothing eliminates there, it's going to be our responsibility to change the equations to where something will eliminate. All right, well, in order for something to eliminate, you have to have a positive and a negative. So just by looking at this, both my x's are positives. But my y's, I have a positive and a negative. So if I could just get these guys to be the same number, just a positive number and a negative number, they could eliminate. Well, if this is a positive 9, I know I could turn this 3 into a negative 9. Well, how would I do that? I'd have to multiply it times 3. Negative 3 times 3 would turn him into a negative 9. But you know our rules for algebra. If we multiply one thing by 3, we have to multiply everything by 3. So we're going to distribute 3 to every single one of these terms. So it's going to change. 3 times 4x is going to turn him into a 12x. 3 times negative 3y turns us into a negative 9y. And then 3 times 15 gives us 45. So I multiplied the bottom equation by 3, and it changed it. And so now I'm no longer going to use that bottom equation. I'm going to use the top equation, and I'm going to use my new bottom equation. And I'm going to combine my like terms just like I did on problem number 1. So if I have 5x's, and I come down here and I have positive 12x's, 5 plus 12 gives me 17x's. Now here if I have positive 9y's, negative 9y's, 9y minus 9y, those guys eliminate. So the y's are gone. And then my constants on the right, I have a 6 and a 45. 6 plus 45 is going to give us 51. So I'm just left with 17x equals 51. Let's solve for x. We're going to divide by 17. And 51 divided by 17 our x value is 3. So on our solution here, our x value goes first, and he's a 3. So now I need to take that 3 and I need to plug it in. Either equation you choose. You actually have 3 to choose from now. Any equation you choose, you can plug your x in and solve for y. I'll just use the top equation. So the top equation is not going to be 5 times x anymore. It's going to be 5 times 3, since I found x to be 3. The top equation says plus 9y equals 6. So now, since I plugged 3 in for my x, now I can solve for y. 5 times 3 gives me 15, plus 9y equals 6. We will subtract 15. So now I've got 9y equals 6 minus 15, negative 9. And solving for y, we are dividing by 9, so the 9 cancels on the left. And negative 9 divided by 9 gives me negative 1. So my solution there would be 3, negative 1. The x value comes first, the y value comes second. Flipping it over, number 6. Number 6, the x's do not cancel right off the bat. The y's do not cancel right off the bat. So I'm going to have to multiply. All right. Now remember what I said. I need a positive and a negative in order for something to eliminate. Well, if you look at your x's, I've got a positive and I've got a negative. So that's nice. I just need them to be the same number so they'll cancel. So this is negative 10. How can I turn this 5 into a positive 10? By multiplying it by 2. But I can't just multiply one of the guys by 2. I have to multiply every term in there by 2. And I'm going to write it on the bottom. So 2 times 5x gives me 10x. 2 times negative 3y gives me negative 6y. And 2 times 5 gives me 10. And I will not use that top equation anymore because I rewrote it. I changed the way it looks. So now if I combine my like terms, negative 10x plus 10x, that cancels. Combine your y's, positive 6y's minus 6y's. That also cancels. So if everything cancels over here, I just have 0 left over. And then on the right side, you have an 8 and a 10. 8 plus 10 is 18. So just like substitution, when your variables cancel, I look to see if my numbers that I have left are true or false. 0 equals 18. Is that true? No, that's not true. That's false. Therefore, we have no solutions. If it would have said 0 equals 0, that would have been true. Infinite solutions. If it would have said 18 equals 18, that would have been true. Infinite solutions. But 0 equals 18, false. No solutions. Last one, 11. 11. My x's do not eliminate right off the bat. My y's, those do not eliminate right off the bat. So I'm going to have to do some multiplication here. Can I somehow turn my 3 into a 4? Can I multiply to turn him into a 4? No. Can I multiply this 2 to turn him into a 7? No. Now, I am going to choose to work with my y's here because one's negative and one's positive. That's the first step that I need to eliminate. But since 2 can't turn into a 7, I'm going to have to change both of these numbers. Right? And so what can I change both of these numbers into? I can change them into a 14. Well, how would I turn negative 7 to turn into a negative 14? I'll multiply it by 2. So when I do that, I'm going to write it down here at the bottom. 2 times 4x gives us 8x. 2 times negative 7y gives me negative 14y. And 2 times 10 gives me 20. And so I'm going to get rid of that top equation because I rewrote it. Well, if this is a negative 14, then I need my bottom equation to turn into a positive 14. Well, how am I going to turn 2y to turn into a 14? I've got to multiply them by 7. So I got to multiply everything in this equation by 7. 7 times 3x, and I'm going to write it down here at the bottom, 21x. 7 times 2y is positive 14y. And on the right-hand side of the equal, 7 times negative 7 is negative 49. Now, and I'm going to get rid of that equation. Now that I have my two y's that are opposite, they can eliminate. Negative 14, positive 14, those eliminate. So when we combine our x's, 8 plus 21 gives me 29 x's. And then on the right, negative 49 plus 20, or you could say 20 minus 49 is going to be negative 29. And to solve for x, we divide by 29 on both sides. And x equals negative 1. So there's the first part of my solution. Now you can take that x value of -1 and plug it into either